to false positive, because you might find something that due to some semantic logic or semantic restriction might never be invoked at this case, but it's going to be found by the tool or by the technology anyway. So no matter what you're doing, you're kind of going to introduce something that you don't want to have. The other thing is, and for this the code is a little bit more complex, the first part is a servlet, the other part is a JSP page. So the servlet is doing something, well in this case contrived, not something really useful, but then afterwards forwarding it to the JSP page. So here I'm reading a parameter from the user, putting in some attribute, and then outputting it later on in the view. So it's kind of like the business and the presentation layer here. And there are actually two problems here. One is the invocation sequence. So as you saw before in the struts example with the workflow here, it might not be really clear what JSP page is going to be invoked afterwards, because that might depend on the return value that you're giving back to struts. In this case, it's a JSP, it's a servlet, so that would be clear. But imagine this part actually being an action. So it's unclear which of the two are going to be invoked in what sequence by just looking at the source code, because that's going to be glued together later on by the framework. So if I'm looking at the JSP first, I don't know where the attribute came from. That could have been set before, that could have not been set before, this could be empty. The same if I'm looking at the servlet first, I don't know yet where the attribute is going to go. Only if I look at this JSP afterwards, and there might be hundreds of others, so I might pick the wrong one, I can actually establish the flow. The other thing is kind of related to this, what I call cross-context propagation. So data is propagated between through a context, across a context, between two parts of the application, between two entities. So in this case, I kind of showed that before by the attribute not having exactly the same name by using concatenation once. Chances are that the attribute operations here are not as clean-cut as one might assume. There might be iterations, so you're actually putting something into all possible attributes. And at compile time, I don't really know how many attributes they're going to be. If you're taking one out and it wasn't seen before in the same way with the same string, or worst case scenario, this is actually not a string. When you're accessing it, you're using some kind of variable. Nobody knows what's actually going on here, so you might miss something. And if you look at the result of the tool, it will give you something. Well, I found a source, get parameter. I'm kind of tracking it into this attribute here, but now I'm hitting this output, and I'm not really sure, is this a sink? So is this a vulnerability that I should flag, or is it not? And like before, we're having the same case. If we assume the attribute is clean, we could have a false negative, because it might actually be tainted previously if the invocation sequence was correct. So we're missing something. Or if I always assume it's tainted, because I think, well, I want to be on the safe side, I'm risking a lot of false positives. So I'm going to raise a lot of alarms that actually are not founded on anything substantial here. So to give a summary of the flow disruptions, we have the URLs that invoke actions, which are not really obviously from the source code. You need to check with the XML where that's coming from. You have the actions that forward to view, so the whole separation between business logic and the presentation, which again is not obvious from the source code. You need to check the configuration XML to see what the invocation sequence is here. And the views output data, again, separation of business presentation, they output data that were computed somewhere else. Well, due to the separation of these components, the computation somewhere else must be propagated to the view so they actually have access to this, and this probably will also happen in a way that is not really obvious from the source code. So in most cases, you actually can't even use a common context that is available in both places by just the name to match it. It might be some additional context that's created on the fly and passed to the view, which magically links in the background to another context with a different name that was available to the action previously. So the challenges that you're kind of exposed to is for struts in particular. If you want to understand the application, you need to understand the XML file that's going on. So you'll have to parse that and figure it out. If you're talking to struts 2, you might actually even have to look at annotations. So not only at specific files, you have to parse the complete source code and figure out what attributes or what actions are annotated with what. And in general, this means the tool needs to understand the framework and it needs to model the framework correctly. Well, that kind of causes a number of problems. what frameworks do you support? So let's say you're writing a tool and OWASP has Horizon and other projects too that are going in the same direction. Let's say you're done with modeling the Java standard environment or in PHP or whatever you're using. Now what's your next step? So do you want to start with the most popular one? Well, chances are that the first use case that you have, or if you're commercial, the first customer that comes along says, oh, that's great that you're supporting Spring, but I'm actually using Struts 2.5, which just came out yesterday. And then you again have a problem, so you need to start kind of from scratch and deal with this. The other thing that you're going to run in very often is, well, you know, we're not using Spring, that's too complicated, we have our own little thing, and we developed this for 2 years, and it kind of works, you know, we still have some bugs, but could you just please scan this? And then you run into cases where, you know, everybody has their own XML file with their own syntax and with their own stuff, and others are more on the side of DSLs, or you can have their own framework in a framework that defines what's actually going on, so this whole over-engineering comes in. And then all of your nice support that was thought out very well suddenly goes out the window. So this all sounded kind of, well, why don't we use this at all now? You know, does it actually work at all? There are a couple of solutions that you can do. Starting with the worst, or the not too happy one, would be you require the user to hardcode the configuration. So you say, well, I build a tool that is completely configurable, so you can do with it whatever you want to, you just have to tell me what I should do. And then you're actually in the case where you're again putting all of the work on the user side, and the user needs to understand what you're actually doing. So you're building a framework to scan other frameworks, and things kind of get complicated. You're probably going to be able to pay a lot of consultants, a lot of good fees to deal with this, but then that's not really the path if you want to do in interest of, well, interoperability and also making it easy to use. You could hardcode support into the tools. So you can say, well, I built my tool and I'm going to support these and these frameworks, and if you use another one, then you are out of luck, but at least these are good. Well, then again, you kind of want to start doing it in a way that is extensible. So if you support the first framework and you want to support the second one, you might not want to start from scratch. So there's also a lot of work that you need to put in there. You're only doing it yourself. You're not sharing this with anybody, so not the perfect solution either. And one idea that came up, or that is actually worth pursuing, is you dynamically translate this magic that's going on in the background into code and potentially make this available in front of the tool. So kind of put a little tool in front of the other tool that handles the translation between the magic of the framework and what is actually going on inside the tool. So before, you would have a model where you take the source code and you just directly submit it to the tool, and the tool knows how to deal with the source code and does its thing. But that kind of leaves out the whole framework configuration, which is not represented in the source code, and the tool doesn't know about it. So, excuse me. So the idea would be to actually introduce something I would call a glue code injector. So the glue code injector would be a little tool that reads the framework configuration, or is able to deal with a number of configurations, or maybe you have a different injector for every framework. And that is pre-processing this configuration, injecting necessary code fragments into the original source code, and then submitting the whole bunch into the analysis tool, which now would resolve the ambiguity in code form, which is something that the tool can deal with, because it's built to deal with code. It just doesn't know about the configuration before. So if the configuration is available in a code form that it can understand, that will resolve the whole issue. To give an example, a very simple and contrived example, obviously there are a lot of issues here that would have to be resolved. How that would look like. This is a struts configuration file in this case, one of the XML files that I mentioned before. And the first thing you want to do is you want to resolve the reflection ambiguity. So in the beginning, when the URL is being parsed, you need to figure out what is going where. Well, this is all inside this XML, right? In static analysis, you don't really care what URL invokes what. You might care if you later on want to generate some attack URL, or you want to use this further. But right now, you just want to figure out what are the actions that are actually invoked, so that I'm not going into any action that might never appear in here. It might be coded, it might be leftover code from before, but I don't want to invoke it, because it in the real application would never happen. So in this case, you could just look at the correct place and transform this into something like this. So instead of this whole reflection, you just directly invoke the action and execute it further on. Obviously, I'm leaving kind of out the interesting part here. So what do you invoke this with? What kind of parameters do you pass in there? Where do you get these from? That obviously would depend on the specification or on how the tool will deal with it later on. The other part is the controller and views. So there was the part where something is being passed over to the view, and you don't really know what view comes from what action. So in the same way, you figure out, well, if I have this particular action, these two views are possible, depending on the parameters. And in static analysis, at this point, you don't really care about what is being invoked in what case, because that depends on user input in most cases, which you cannot predict anyway, so you want to go into both cases. And you could extend this by saying, okay, if what condition, which again would depend on how this other tool or your particular implementation interprets this, go to either of these two, and then again you have a code that the tool can deal with. This is hard-coded strings. I can find these files. I know these classes. I can find them. So I just take those and run with it and have actually a usable model of the framework in this case. And again, this kind of is very simple. There are obviously a lot of issues that we have to deal with, but it's something that can make this work. So you have a simple and effective workaround with no impact on the implementation or the code of the application, because that's the other important part. If you're going to go in the path where you say you want to configure, the user has to configure everything, this has to go somewhere. And chances are, if you don't want to contain, another configuration where you list all your action, and then you have the action itself, you change the action, so you have to change your configuration for the tool. In this case, you don't need to worry about this, because the parsing of the configuration, which kind of goes together with your source code, is handled by the glue code injector, and the code itself doesn't have to be touched. So the developers will be rather happy because this is completely transparent to them. You would have also several options. The glue code injector could be a standalone or third-party implementation that you just hook in front of the tool. That obviously depends on how the tool is reading the source code or how your implementation of the static analysis looks like, how that would fit in with taking the source code and amending it and then passing it on. It could obviously be bundled with a tool. That would kind of assume there's an open standard or there's some kind of accepted way on defining how the glue code injector should work, which obviously would be the more complicated approach, because then you first have to have a common understanding on what does the glue code injector do and how can it be configured. It's not a perfect approach, obviously. If you look in what the frameworks are actually doing, this stuff is really complex and gets more and more dynamic and more flexible, which is what you want because it gives you more option in writing web applications. But it obviously makes dealing with this stuff harder because you have more and more things that you have to model, and some of them might not be modeled easily with just a couple of if statements. They might require some more advanced techniques, while still making sure that you don't use any of the reflection or invocation sequence or cross-context propagation parts that you can't really deal with. The nice thing here is tool would be applicable to homegrown frameworks. So if you actually have your own framework, the only thing that you have to add is your own glue code injector. But depending on how complex your framework is or how well these glue code injection techniques would be defined, that might not be that big of an issue. So no matter how you're handling your own extended web application, you could actually integrate that very nicely. And obviously extends the coverage of the automatic analysis quite a bit. So again, this is not a super, I heal everything solution, but it would at least increase your coverage and you find more vulnerabilities that you weren't able to find before, or you can look into more classes that you weren't able to look into before, which is already a step in the right direction. Just a quick overview of how this extended coverage could actually look like. And again, this is just for demonstration purposes. So you start out, in this case, with your glue code injector that says, well, I'm going to start here. This is the action that you should invoke. You actually run the code from the source code itself. So the tool knows, oh, okay, I'm going to go here. There's your action. I'm going to, do whatever it takes. And after it's done, it returns something which you then ignore. You just say, well, whatever you got back here, these are the paths that you want to take now. And from there, you go into the source code again, into the